And today in this video I'm going to tell you about the division of polynomials. In my last video you got information about addition, subtraction and multiplication of the polynomials by this way, and we are going to start the division of polynomials. You know that for division of the polynomials, if you divide a polynomial px into qx or into dx, so the case for division of the polynomials will be equal to px is equal to qx multiplied by dx plus rx, where px is a polynomial by the name of dividend, qx is a polynomial, the coefficient of the polynomial, and of the division form, and dx as the divisor, and rx, you know that this is the remainder of the polynomial. So this is the shape for the polynomial, and if you divide a polynomial px over dx, the quotient will be qx and the remainder will be rx. You can write in this method. So for polynomial, you have to see what is an example. Let's have an example for the polynomial. See, very simple example. Looking back, yes, an example, find the quotient at x to the power of 4 plus x plus 2 when it is divided to x plus 1. The method and we can use this division form. See how to solve this question. First, write the polynomial here, px. We write the px x to the power of 4. You know that px is not a complete polynomial, and if you are going to complete this polynomial, you have to write it like x to the power of 4 plus 0x3 plus 0x2 plus you have x to the power of 1 plus 2 x to the power of 0. So this is the complete form of the polynomial. So x, you can write as 0 to x to the power of 3 plus 0x2 plus x plus 2. And now what will be the quotient of this polynomial if you divide it to x plus 1? So in division you have to divide first term of the this polynomial px to first term of the divisor. To first term of what? Yes. The first term, it means x to the power of 4 divided over x. The first term of polynomial dividend, you have to divide it to the first term of divisor. This one to this one, or this one to this. So here, x to the power of 4 divided to x. The answer, according to power rule, it will be x to the power of 3. So write x to the power of 3 here, x to the power of 3. Then multiply this by that, and by this divisor. X to the power of 3 multiplied by x is equal to 1. X to the power of 4. And x to the power of 3 multiplied by 1 is equal to x to the power of 3. So now that you have to change the signs. In subtraction, you have studied that you have to change the sign of the second polynomial. So this will be you can count is cancelled. So you can write negative x to the power of 3. Now bring 0 x to the power of 2 plus 0 x to the power of 2. And let's have, once again, divide the first term of this divided to the first term of divisor. It means negative x3 divided over x. The answer will be negative x to the power of 2. Now bring x to the power of 2 here, negative x to the power of 2 here, then multiply it back to this number, to this divisor. X to the power of 2 is equal to, multiplied by x is equal to x to the power of, and the sign will be negative. Negative positive is negative. Negative x to the power of 3 minus plus is equal to minus. X to the power of 2 multiplied by 1 is equal to x2. Now, once again, change the signs. So, it will be cancelled. So, here is 1x. You can write 1 plus 0 is equal to 1x to the power of, here is 1x to the power of 2. X to the power of 2. And now the term is for x. What? For x. If you don't mind, I will write it here. x2 plus x. Once again, divide the first term of dividend into the first term of divisor. It means x2 over x. The answer will be x. So bring x here plus x. X multiplied by x is equal to here x2 plus is equal to plus. X multiplied by 1 is equal to x. So change the signs. Here is positive, you have positive is negative, positive is negative. And here as well as you can cancel this. And positive x is cancelled with negative x. So here you have what? 2, positive 2. It means you have here, bring positive 2. Positive 2, that's called what? 2 is remainder. Remainder, see? And this diagram also, 2 is the remainder. Quotient, this is quotient. It means this is our answer. This is our answer. Quotient is there. So divisor, what is divisor? This is what? Divisor. So, and this is dividing polynomial. It was a very short example about division of the polynomials. If you have any question, then share with us. So, and I'm going to find this remainder by other method. How to find the remainder without this long division? Without the long division, I'm going to find the remainder. In this case, you have to see the term. Welcome back. Yes, the term is if a polynomial px is divided by what? X minus t, the remainder is the constant pt. You know, for division, you have px is equal to bx multiplied by qx plus r. That was the term for division, or that was the case for division. So if in this polynomial, if you divide px, divide over x minus t. If you divide it into x minus t, so that remainder is the constant pt. How to prove this? See? How to prove px is equal to x minus t, so you have to write it like this. If you divide px over x minus t, so you have to apply this case into this one. Px is equal to x minus t means x minus t multiplied by qx plus r. So if you put x minus t equal to 0, reason x is equal to t. So put instead of x, t. P of t is equal to t minus t q t plus r. So p of t is equal to 0. T minus t is equal to 0 multiplied by q t plus r is equal to 0 plus r is equal to r. The reason p t is equal to r, and that was the case. The remainder is the constant pt. Pt equal to r, r means r is a number. 2, 3, 4, 5 is a natural number, so maybe it will be negative number, so it's constant at all. So that was the term that I solved to you. So let's have an example for how to find remainder without long division. Welcome back, everybody. This is the last example. That is now I'm going to find the remainder. Without long division, find the remainder when x4 plus x plus 2 is divided by x plus 1. Without long division, in this case, if you're going to find the remainder, it means find what? R. R is equal to 1. So Third, here is a polynomial. So px is equal to x4 plus x plus 2. X plus 1, x is equal to x plus 1 is equal to 0. So put a plus 1 equal to 0. Here, can you find x? Yes, x is equal to positive 1 gives to here negative 1. So find p negative 1. And every cases you have to change the sign. It means if there is x negative 1, so you have to put instead of x positive 1. If it is x positive 1, so you have to put it x negative 1. If it is x plus 2 or positive 2, so put it negative 2. If x is negative 3, so put it positive 3. etc. So it will be equal to negative 1 to the power of 4 plus negative 1 plus 2. So p negative 1 will be equal to 1 to the power of 4. It means 4 times 1 is equal to back positive 1. You know that is even. Plus negative is negative 1 plus 2. And here p negative 1 will be equal to, this is cancelled, 2. As you saw in the example that I solved before at first, that was, there was the remainder 2, and you can find it also by this method. And let's have a very short other term. Welcome back, and I'm going to prove the second term of division and polynomials. This is term 2. If px, which is a polynomial, is divided by what? By sx negative t, then the remainder is the constant p t over s, the same like last term. So the proof is the same like the last term. That was, you know that if you divide a polynomial px, px into bx, now so will bx, the case was bx multiplied by qx plus r. It was the case for what? Division in polynomials. So for proof, you can write it like if you divide px into what? If you divide px into sx minus t, px divided to sx negative t. So you have to write it like px divide bx is the same like sx negative t. Sx negative t multiplied by qx plus r. And px is, as you know, that plus sx negative t is equal to 0. So sx is equal to t, then x is equal to t over s. Now put this x here. P instead of x what? T over s. T over s is equal to, yes, that was equal to what? S multiplied instead of s, t over s, negative t. Q instead of x, t s plus r. So p t over s will be equal to, s is cancelled with this, s is with s cancelled, and t minus t is equal to 0. 0 multiplied by q t over s plus r, and it will be equal to what? 0 multiplied by this is equal to 0 plus r, and is equal to r. That was the case for the which one? R is the constant pt over s. At the reason, you can write it like pt over s is equal to r. And this is the case for the second term of division and polynomials. And let's have one example for this term as well. Hi my dears, welcome back, and I'm going to solve this question for you. With a long division, find the remainder when x3 negative 3x plus 4 is divided by 2x plus 3. Very simple for solution of this question. You have to write it like, this is the polynomial p, x is equal to x3 negative 3, x positive 4 by 2x plus 3. It means it is divided by 2x plus 3. So find x here. First find x. Here you can and put it equal to 0. 2x is equal to negative 3 and divide both sides by 2. It is equal to 2 with 2 is cancelled. So the answer x is equal to negative 3 over 2. Now put this value in this polynomial. It means find what? P instead of x. Negative 3 over 2. Negative 3 over 2 is equal to what? Negative 3 over 2 to the power of 3, negative 3 multiplied by, instead of x here, negative 3 over 2, positive 4. So it will be equal to, now let's have very short answer. If you have 3 negative, the answer would be negative. 3 negative is negative because negative is positive. Once again multiplied by negative is equal to negative. So 3 to the power of 3 is equal to 27 and 2 to the power of 3 is equal to 8. Negative, positive, negative is equal to positive 9 over 2 plus 4 and is equal to, here you have to find a common factor for this question. That is the denominator for this number is 1 and 8 will be common between, and the LCM will be 8. 8 divided by 8 is equal to 1. 1 multiplied by 27 is equal to 27. Plus 8 divided by 2 is equal to 4. 4 multiplied by 9 is equal to 36. Plus 8 divided by 1 is 8. 8 multiplied by 4, 32. Now let's have the addition of this. So very simple. You can negative 7 write in this. Find the addition form is equal to what? 68. 68 plus 68 over 8. And the final answer is equal to what? The final answer is equal to 8 minus 7 is equal to 1. And 6 minus 2 is equal to 4. 41 over 8. So this is the reminder for this question. And thank you for watching this video. Have a good day and night. Goodbye. I forgot to tell you about the homeworks that you don't like to do it. Please do the homework. These are your homeworks.